Okay, this is the mission to refuel the Moon Survey Mission Lab. We are going to go into orbit, hit the lab, and that's convenient because Mooner Station is just in the right spot at the moment, approximately. Let's go forward a little bit. Slightly north inclination. Launch in 3, 2, 1. This is going to be a fairly top-heavy spacecraft, so we want a very steep ascension angle. I'm going to go up pretty much exclusively until we hit about 10K, and then tip over relatively fast. It's not optimally efficient, but it will avoid aerodynamics issues. I discovered this new flight data section of for aerodynamics, which, among other things, tells me the terminal velocity, so that's handy. I just have to make sure I stay below terminal velocity for any given altitude. And stage. Apoapsis at a kinda low. The thrust-weight ratio for this rocket is not very good because it has Kerbals on board. The original version of this rocket had a autopilot, but my communication satellite network isn't very good, so I couldn't guarantee orbital coverage. So I ended up going with a manned mission. Wave hello, Dilnard Kerman. Dilnand Kerman? Yes. Good. Time to apoapsis is increasing steadily, and we're guaranteed 10 kilometers, and we're still on target. I think we could start tipping over soon. Just a little bit. And since the inclination of our target is a little bit north of east, we're going to try and go a little bit north of east on our ascent, but that's not generally achievable very easily. Come on, tip over a little bit. This does not want to tip over. But as the air resistance becomes less, it should become easier to tip over. Our control surfaces, the wings, aren't biting very strongly. But once we drop these two side rockets, the vectoring engines on the central core will start to make more effect. I can definitely tell that as the air pressure decreases, it's becoming easier to turn. I'm getting less resistance, which is this number here. Good. Apoaps is reaching, let's say 75, then we should cut engines and wait until we're closer. And then we can do our final orbital insertional burn. Feedback from Alira, the girlfriend, says that I was talking in too high a pitch for my last video, so I'm making a little bit of an effort to lower my register a little bit. Alright, Apoaps reaches 75. Cutting engines in 2, 1, 0. That looks pretty good. How much fuel do we have left? Not bad. That should be more than enough to finish our insertion. According to this, we have 1200 and we're going at 900. That will give us approximately 2200, which might not be enough, but I brought a little extra fuel just in case. While we're waiting, I'll just top up this fuel tank a little bit from our reserve. Good. Aim for the horizon, and we want to hit... Oh, beautiful. The station is just at about the right spot. In fact, we want to raise a little. I think we might be able to do our intercept right away. Okay. I'll just try to keep on the same inclination as the station. And this time we actually want to keep raising our apoaps instead of doing a straight orbital insertion. Good. Let's keep time to apoaps around 10 to 12 seconds. Fantastic. That's coming along pretty quickly. In fact, let's just zero ourselves relative to the target. Cool. Out of fuel. That's no problem. Let's just transfer some. Okay, we're going slightly above the lunar station orbit, which means it will actually be able to catch up a little, which is what we want. So if we increase our distance above its orbit, it will be able to catch up even further. I've refilled the tank there. That's good. The reason this is working is because we're on a pretty close approximation of the plane, and we're going above its orbit to let it catch up. Perfect. Separation is now increasing. How are we on target? We are very slightly north of it, so let's do a southward burn to match orbits a little better. This rocket is not very responsive. It does not like to rotate. Actually, I can increase that by turning off attitude control, and then turn on attitude control when we're at... There we go. So if we thrust north, we ought to... Yeah. decrease the intersect. 2.2, 2.0, 1.5, 1.3. That's probably as good as it's going to get. Yeah, let's not waste the fuel. So at this point, all we have to do is make sure that our prograde marker lines up approximately with the target marker. Because we are on almost an identical plane, inclination 3.9, and I remember from previously that the station is also on inclination 3.9. Probably should have staged off these fairings. Well, now I have junk in orbit forever. Click. Jettison. And activate. And I'm only just realizing that I forgot to put a parachute on this pole, so I'll have to do some kind of rescue mission. Looks like I got the solar panels out just in time. Okay, now let's push our prograde marker over the target marker by burning opposite. That is actually increasing the separation. But it doesn't matter as long as we keep our prograde marker on target. Actually, better yet, I should burn against the retrograde marker because we're going at 300 meters per second, and that is uncomfortably fast. Current distance 44 kilometers. And of course, now we've got space junk all around us. At some point I'll have to figure out a way to do that. The thing about space junk is that you're vulnerable to something called Kessler syndrome. Kessler syndrome refers to the concept that when something breaks up in orbit, it creates a bunch of other junk. That junk can in turn veer unpredictably into other objects, which then cascades into a nasty reaction, chain reaction. Kind of like a nuclear weapon, with stuff bouncing into other stuff, and then more stuff. That stuff bounces into other stuff, and then suddenly orbit is not usable for 200 years. That is something that many people would rather avoid. Let's see, we're pointed away from the target. It's still 20 kilometers away. Once it starts to render, see, according to this I have 400 meters per second of delta V, which is probably not going to be enough. Let's use some more of the reserve fuel. Might as well just transfer it all in there. Good. When you're burning retrograde on the retrograde marker, you want to burn on the opposite side of the retrograde marker, which will push it toward your target. When you're burning toward a target, you want to burn on the side where you want it to go. So in this case, I'm burning that way, which will push it toward the target and keep me on it. We're about 30 seconds to target at the current speed, so that's a little too fast. Let's take that down to 100 meters per second. Still about 30 seconds to the target. Once I'm close, I will transfer the fuel out and then stage off. Oop. Actually, we are going too fast. This thing steers like a cow. Let's burn some RCS fuel to keep us. That's better. Keep on the target to 0 our relative speed. Come on. You know what? That's close enough. Time to transfer the fuel that we have left, which is pretty good. And let's get us in closer to the Moonar station. And now, another piece of space junk. Bam. So, we don't have a flight computer at the moment. So, let's orient north. It appears that I do not have a docking port on this particular vehicle. So I'm going to revert this mission and start recording again when I am on the close intercept again. So take it up again in another half hour or so. Whee! And we're back with a vehicle that has a parachute and therefore the ability to get back into the atmosphere without dying and not needing a rescue ship, and with some docking ports that allow us to actually dock with the station and transfer some fuel. The whole point of the entire mission. So, decelerating toward Moonar Station, 120 meters. Slowing down to 0 to synchronize with the station. Now I noticed earlier that both of the docking ports on the station are taken up at the moment. So we're going to have to deal with that by removing one of the vehicles currently docked at the station in order to allow this one to connect. But first, let's get up to 0 relative to the target. I'm actually re-recording the audio for this after botching it up the first time. So I'm playing the video using VLC and recording it again, as I can't figure out how to use my video recorder, apparently. So if there's any weirdness, that's why. And decouple. kind of annoying having to do this in the dark side of the planet. I should make more of an effort to do it on the light side. But I seem to be able to see okay. Intersect separation is good. We should be on a stable orbit. And switching to the station. Get that servo control out of the way. The fuel tanks on the lander are full, so let's detach. And I see there that I undocked instead of detaching, and here I am all confused. Let's try that again. Undock from station. Now we're going to pull out the RCS thrusters and back off from the station a little bit. Once we've backed off from the station, we will rotate Munar Station 1, and that will allow us to dock the refueling vehicle. After the refueling vehicle, is docked, then we transfer the fuel, undock, and deorbit. The other vehicle attached to Munar Station is the Kethane MapSat and communication satellite ferry. Those will be delivering a few satellites into Munar polar orbit. That allows us to figure out where Kethane deposits are for a future mission. It tells us where the biomes are for our survey mission, and it allows us to communicate with Kerbin should we want / need to send science back or to have unmanned vehicles in orbit around the moon in future. Now, switching back to the refueler. I am orienting toward north because Munar Station is also oriented north. Since this vehicle is disconnecting immediately afterwards, it's not terribly important. $10 to dock. Slow down a little bit. We need to go up a little bit. This is not going to be the most elegant dock, but it'll do the trick. The magnetic clamps tend to wobble back and forth a little bit sometimes, especially if you come in at a weird angle like this. But they don't usually detach unless you're coming in at a really fast speed, so if you just let them wobble back and forth for a while, they'll usually manage just fine. Almost there. A little bit to the side, magnetic clamps engaged, and there goes the wobbling. You'll notice I've turned off RCS and attitude control. That just lets it find its own level as quickly as possible. Sometimes takes a while to do it, but it'll do it eventually. Any second now. And docked. Time to transfer fuel. There's no fuel in that bottom tank. That's because we used it to get into orbit. Huzzah. And I'll pause the recording here because transferring fuel is not very interesting. And the fuel is all transferred. Ding. There's a little bit of fuel left in the transfer vehicle, so we're putting it into the ferry. That's handy. If we wanted to get, well, not. If we were lazy, I would transfer fuel into the lander, but that would require an extra docking, so it's not really worth the effort. And it's already mostly full of fuel. Alright, looks like everything has fuel now, so let's undock. And deorbit Dillman Kerman. But before we do the deorbiting, maybe let's get Bill, I think it is, back into the vehicle. Slide away from the lunar station. Turning to point toward our retrograde marker. And burning forward to deorbit. Our periaps is decreasing. Good, there we go. Then once that's out of the way, we'll switch vehicles to the lander. Then dock that back up with the station. Goodbye, little refueler. And skip. And now that this is docked, our lunar transfer can commence. We have lander, satellites, and lab all ready to go. Bill, Bob, and Jebediah will be on their way next time. But before then, I need to disorbit Dillman Kerman's refueler. For that, we want our periaps to be around 40, so that it doesn't skip back out of the atmosphere. He has plenty of life support, but there's no point in tempting fate. food, water, and oxygen at 1.0 means that he has 1 day of life support. An orbit around Kerbin is typically half an hour. In fact, 32 minutes and 59 seconds at the moment. And there we are, periaps at 40. We have plenty of monopropellant left. Monopropellant being the most inefficient possible fuel to use, but it's all we have. An alternative approach would have been to mount separatrons onto the command pod. That's an easy way to make an escape pod from orbit for emergencies. Not that emergencies ever happen in Kerbal Space Program. No, never. You can just... 4 or 5 separatrons are enough to completely deorbit a capsule with nothing else attached, so it's a very nice, light, and simple escape pod. Just point it retrograde and fire it off and wait. It's pretty straightforward. And now that we're at 32 periaps, obviously it's time to make our atmospheric entry. At 69 kilometers altitude, we'll hit the very top of the atmosphere. The gauge at the top of the screen will show that we're not quite in yet, but we don't actually hit the blue area until we're about 60. Since I'm using deadly re-entry, it means that on re-entry, it will start to burn through ablative shielding at the bottom of the capsule. Ablative shielding means that it's just material that absorbs heat and burns off as it heats, taking away the thermal energy away from the occupant of the capsule. An example would be the ceramic tiles on the space shuttle, which absorb and... I don't know if that is an example, actually. I don't think the ceramic shuttles on the space shuttle actually come off. They get replaced every flight. Or did get replaced every flight, at any rate. We're passing through the upper atmosphere now. We won't see significant thermal shock until we get well below the upper atmosphere into the middle atmosphere, which would begin at about 35. If you look at Flight Engineer, you'll notice that apoaps and periaps are both below the atmosphere, which means we're guaranteed to hit the surface. I don't know what it is about Ferrum Aerospace that makes capsules entering the atmosphere spin like that. It's strange. It's easy to counteract. You can just turn on stability control. And I bet those solar panels are going to come off pretty soon with air buffeting, since it's a wind going past us at 1700 meters per second. And there we go, shock heating. You'll notice that I have to turn off stability control to automatically get the ablative shielding pointing retrograde. Actually, retrograde is the... pointing toward, or down, let's say. In the retrograde direction, I suppose. I think that's specifically an orbital term. Anyway. Thermal heating will continue until we hit about 900 meters per second. If you look at the ablative shielding stat and the resource in the top right, you'll notice that it's stopped going down at around 178. If ablative shielding ever goes to 0, your capsule will start to heat up. You probably don't want that. And it looks like we've survived re-entry, and now we're just waiting for an opportune moment to pop the parachute. A good time to do that is around 300 meters per second. Anywhere between 300 and 200 meters per second is a good time, depending on the weight of your capsule. If you have a heavy capsule, or a heavy vehicle that you're trying to slow with parachutes, you don't want to be going too fast because you'll just rip the parachutes right off. But something as light as a capsule, it doesn't really matter so much. 300 meters per second is probably fine. And we're starting to feel the drag. That's nice. One helpful thing to keep in mind on a descent through the atmosphere like this is that you can go inside the capsule on an IVA, the internal view, and look at the dials inside. One of which is a radar altimeter. The top one is vertical speed, the middle one is altitude above sea level, and the bottom one is radar altitude, which is your actual altitude to the ground. That is what determines when your parachute goes off. And if you're not sure what's going on, it's always worth a quick look inside. You don't want to do it for too long because you lose situational awareness. And Dilnand Kerman is safe home from his refueling mission. Now he can go home and get some fresh snacks besides